Hi all. In the previous lectures we have studied the prestressed concrete and the analysis of prestressed concrete B. Then moving on to the losses in prestress. In prestressed concrete applications, it was observed that the prestressing force does not stay constant, but it reduces with time. During the prestressing of the tendons and the transfer of prestress to the concrete member, there is a drop of the prestressing force from the recorded value. These reductions of the prestressing force are termed as losses in prestress. The losses in prestress are classified into two groups. The first one is immediate loss and the second one is time-dependent loss. The immediate losses that occurs during the prestressing of the tendon and the transfer of the prestress to the concrete. The second one is time-dependent loss. The time-dependent losses occur during the service life of the prestressed member. The losses due to the elastic shortening of the member, friction at the tendon-concrete interface, and the slip of the anchorage are the immediate losses. The losses due to the creep and shrinkage of the concrete and the relaxation of the steel are the time-dependent losses. In pre-tensioning, the occurred losses are due to the elastic deformation of concrete, relaxation of stress in steel, shrinkage of concrete and creep of concrete. But in the case of post-tensioning system, the losses occurred are due to the anchorage slip, friction, creep of concrete, shrinkage of concrete, relaxation of stress in steel and due to the elastic deformation of concrete. But in that case, there is no loss due to the elastic deformation if all the wires are simultaneously tensioned. If the wires are successively tensioned, there will be loss of prestress due to elastic deformation of concrete. The first one is loss due to elastic deformation of concrete. In the case of pre-tensioned member, when the tendons are cut and the prestressing force is transferred to the member, the concrete undergo immediate shortening due to the prestress. The tendon also shortens by the same amount, which leads to the loss of prestress. In the case of post-tensioned member, as I said earlier, if there is only one tendon, there is no loss because the applied prestress is recorded after the elastic shortening of the member. For more than one tendon, if the tendons are stretched sequentially, there is loss in a tendon during subsequent stretching of the other tendons. The loss due to the elastic deformation of concrete is quantified by the drop in the prestress in a tendon due to the change in strain in the tendon. Assume that the change in strain in the tendon is equal to the strain in concrete at the level of the tendon due to prestressing force. This assumption, that means the change in strain in the tendon is equal to the strain in concrete at the level of the tendon. That assumption is known as strain compatibility equation. Let Fc is the prestress in concrete at the level of steel and Es is the modulus of elasticity of steel and Ec is the modulus of elasticity of concrete and alpha is equal to Es by Ec. That, as you know, that is called modular ratio. The strain in concrete at the level of steel, that means the strain can be found out by using the equation strain is equal to, or modulus of elasticity is equal to stress by strain. Therefore, strain can be calculated by stress by modulus of elasticity. Similarly here, strain in concrete at the level of steel can be found out by using Fc by Ec. That means strain is equal to stress by modulus of elasticity. Similarly, stress in steel corresponding to the strain That can be found out by using stress is equal to strain into modulus of elasticity. Strain into ES. As per the compatibility equation, the strain in steel and strain in the tendon can be equal to the strain in the concrete at the level of steel. That's why SC by EC into ES. And ES by EC can be substituted by alpha, that alpha is modular ratio. Therefore, loss of stress in steel is equal to alpha into FC. This loss of stress in steel due to the elastic deformation of concrete or elastic shortening of concrete depends on the modular ratio and average stress in concrete at the level of steel. Next is losses of stress due to friction. In post-tension members, the loss of stress occurs due to the friction between the tendons and the surrounding concrete decks. Normally, the friction generated at the interface of concrete and steel during the stretching of a curved tendon in a post-tension member leads to drop in the prestress along the member from the stretching end. The loss due to friction does not occur in the case of pre-tensioned members because there is no concrete during the stretching of the tendon. This loss of stress due to friction consists of two parts. The first one is loss due to curvature effect. That depends upon the tendon alignment. That means the first one, that's loss due to the curvature effect. The friction is generated due to the curvature of the tendon and the vertical component of the pre-stressing force. The second one, loss due to wobble effect. In addition to this friction, the stretching has to overcome the wobble of the tendon. The wobble refers to the change in position of the tendon along the duct. That depends upon the local result of the accidental misalignment. The loss due to friction that depends upon that is proportional to the coefficient of friction between the concrete and steel, and that is also proportional to the vertical reaction from the concrete on the tendon due to curvature. It depends upon the coefficient of friction, curvature of the tendon and the amount of pre-stressing force. The friction due to wobble is proportional to the length of the tendon and the pre-stressing force. The wobble in the tendon depends upon rigidity of sheathing, diameter of sheathing, spacing of sheath support, type of tendon and type of construction. If you are considering a section like this at a distance of x from the tensioning end, the magnitude of the pre-stressing force Px is given by P0 into e raised to minus mu alpha plus Ks, where P0 is the pre-stressing force at the jacking end, mu is the coefficient of friction between the cable and the duct, and K is the friction coefficient for wave effect. As per IS 1343-1980, that is the IS code for the pre-stressed concrete, this table gives the value of mu and the value of K varies from 0.0015 to 0.005 per meter length of the tendon. The next is loss due to anchorage slip. In a post-tension member, when the pre-stress is transferred to the concrete, the wedges slip through a little distance before they get properly seated in the conical space. The anchorage block also moves before it settles on the concrete. So there is a loss of pre-stress due to the consequent reduction in the length of the tendon. The magnitude of this slip depends upon the type of the anchorage system. If delta is the slip of anchorage in mm and L is the length of the cable in mm and A is the cross-sectional area of the cable, and ES is the modulus of elasticity of steel, and P is the prestressing force in the cable. The slip anchorage delta can be obtained from PL by A into E. Therefore, loss of prestress due to the anchorage slip, that means P by A, can be calculated from this equation. P by A is equal to ES into delta by L. From this we can calculate what will be the amount of loss of prestress due to anchorage slip. Thank you.